Hey everyone, this is notes number 13, reference angles. Go ahead and write down the FLT here and then we'll go ahead and get started. Just a reminder that you should always pause whenever you need to, either write things down or to reflect when I ask you a question, okay? Okay, so here, given an angle, you're going to be able to draw this triangle that we're going to talk about and identify the reference angle, okay? So, the whole idea of this is, we're going to try to incorporate trigonometry, sine, cosine, and tangent, and the reciprocals, in order to find the ratios of any angle. So before we can do that, there's something called a reference angle that I'll talk to you guys about. So let me go ahead and show you the first example here. It looks a little bit like this, and I want you to actually write it down in its entirety. So make sure that you write down the instructions as well as this picture here, but then you'll learn to shorthand everything afterwards, okay? Okay, so they're going to provide you an angle, and you're going to have to illustrate what that looks like, okay? So let me show you here in this example, and hopefully I still have it. Do I still have it? Ah, shoot. Okay, so I'm going to have to go back. Where did it go? Okay, right here. So the angle may be a little bit different, but let me... Okay, so let's write 154 instead of the 120. I think I had 125. Write 154 here, okay? So what you're going to have to do is, you see this yellow dot right here? Your initial side always starts on the positive x-axis. So you always start here, and then you're going to go counterclockwise. You're going to go against the clock, okay? Okay, so what you're going to do is you're going to hold your mouse, or if you have a touch screen, you're going to hold that yellow dot, and you're going to go counterclockwise. And notice how when you go counterclockwise, on the upper left here, they tell you what the angle is. So right now it's currently 15 degrees. And notice how it makes a triangle, right? Notice how that triangle is hugging the x-axis here. Now I'm just going to go all the way through. So as you move on, the triangle is being built. But notice how when you go to quadrant 2, it's also hugging the x-axis, okay? And notice how when you go to quadrant 3, the triangle is also hugging the x-axis. And notice how when you go to quadrant 4, it's hugging the x-axis. So notice how no matter what quadrant you're in, the reference triangle is hugging that x-axis there. Okay? So more on what this means. So let me show you here. Okay. So I guess we can stick with 125. So what's happening here is I can't really animate it for you, but 125, think about where 125 degrees is. Which quadrant does 125 degrees fall under? Okay? So recall that when you go from here to here, that's anything from 0 to 90 degrees. And then quadrant 2 is anything from 90 to 180. Quadrant 3 is anything from 180 to 270. And quadrant 4 is anything from 270 to 360. It makes a full circle. Okay? So I know that 125 degrees is definitely somewhere in quadrant 2, because it's between 90 and 180. So here's what you do. Now, I can't be as accurate as Delta Math is because it actually tells you what the angle in degrees is. So I'm just going to estimate this for you guys, okay? So I know that I'm going to have to sweep out all the way until I get to about here. Okay? And what you're going to do is you're going to go ahead and draw a terminal side from the origin. That's the very first step, okay? There's no need for this other stuff. That's just to show you how far you need to go. Okay? And here is the trick, you guys. When you make your triangle, you always hug the x-axis. So from the tip of that orange, you're going to go down to hug. Okay, here's what you don't want to do. You don't want to hug the y-axis because that is not a reference triangle there, okay? So remember, wherever you are, you always hug the x-axis. And this right there is your reference triangle. Now, what the heck is a reference angle? And that's what you guys are working on, okay? So you know, and I'll draw it in a different color here, that from here to here, that is 125 degrees. Okay? The reference angle is this acute angle right there. Let me make that a little bit larger. That's 125 degrees, and that angle right there is some theta. That is your reference angle. Okay? So using logic, okay, don't try to stick with rules, you guys. We have to figure out what this reference angle is. So the way that we do that is we use what we know. So let me go ahead and kind of illustrate this. We know that from here all the way to here, that is a semicircle. A semicircle produces 180 degrees. A semicircle produces 180 degrees. So if that blue angle right there is 125, how do we figure out that missing reference angle? Pause, really think about it, and then press play when you're ready. Okay, so logically, the only way to figure out theta is if we take 180 degrees and then we take away the 125 degrees. That'll give us theta. So that reference angle is going to be 55 degrees. Now, why is a reference angle so important? We'll talk about that later, okay? And that's it, okay? So the reference angle is 55 degrees. Your reference angle always has to be acute, meaning it has to be less than 90, okay? Okay. Now, here's part B, 49 degrees. You could shorthand this. You don't have to write everything down. 49 degrees, where would that triangle be, right? And what quadrant would that triangle be? Press play when you're ready. Okay, 49 degrees is easy because it's somewhere between 0 and 90. So we're going to sweep out until about 49 degrees, which is about here. And you're going to draw that terminal side. And again, you guys will have more accuracy because when you do it on Delta Math, this will actually change to 49 degrees. So you know where to stop. But make sure that you go counterclockwise, okay? I'm going to get rid of the dots here. Okay? So the most important step, drawing your triangle. Okay? Remember, you always hug the x-axis. So I'm going to travel down and then hug the x-axis. Okay? That makes a right triangle right there. So here's the thing. I'm going to make this a little bit larger just so you can see. Let me see if I can duplicate this. Okay. Oh, that's okay. So we'll deal with that. Okay, so I'm just zooming in over here, okay? So it turns out that the amount that I sweeped out was 49 degrees. But notice how 49 degrees is already acute. So whenever you're in quadrant 1, it's super easy to find the reference angle because if you're in quadrant 1, the angle is your reference angle. So here, theta is just 49 degrees. There's no need to add or subtract or anything there. Whenever you're in quadrant 1, the angle is your reference angle. Okay? Whereas the last one, 125 degrees was definitely not acute, so we actually had to find out what that green theta was. And we knew that a semicircle was 180, so we just subtracted 180 minus 125 there, okay? Okay, so let's try another one. Here's 237. Think about where you'll be. So if you're doing this by hand, what I would first do is I would first draw an X and Y axis. And then think about where 237 is. Press play whenever you're ready. 237 is definitely somewhere in quadrant 3. So I know that I'm going to have a terminal side in quadrant 3. So I'll even illustrate it. This right here is 237 degrees. Okay. Now remember, the most important step when you draw your triangle, you always hug the x-axis. So it makes sense to go upwards to hug the x-axis. Okay. Now this one is probably the most challenging type of problem when you're in quadrant 3. People tend to approach it a little bit differently. Okay. I want you to logically explain what theta should be. Press play when you're ready. Think about what theta should equal here, okay? Okay, so logically speaking, that blue loop right here is 237 degrees, okay? So in order to just get this little chunk here, I would have to take away that semicircle. If I take away that semicircle, I will have just that blue angle right there highlighted. So the only way that makes sense is if I take 237 and I take away the 180, the semicircle. That'll give me the rest. So here it's a little bit different in quadrant 3. If you subtract that, oh gosh, what do we get? We get 57 degrees. That is your reference angle. That is how much this is worth right here. Okay? And it makes sense because from here to here, that's 180. And from here to here, that's 57. If you add that together, you get 237. Okay? So in quadrant 2, we subtracted from 180. 180 goes first. In quadrant 3, we subtracted to 180. So 237 minus the 180. Okay, so a little bit different. You could stick with rules, but I really don't encourage it. Just think about it logically. How would you get that leftover piece? Okay? All right. Here's another one for you to practice. Here's 168 degrees. Okay, draw your reference triangle, your angle, and your reference angle, okay? Press play when you're ready. 168 is definitely somewhere in quadrant 2. Okay. Now, you know, delta math is very accurate with the triangle. Overall, it really doesn't matter where you draw it as long as you're in the right quadrant. Okay. So you could even draw it, just to give you an example, you could even draw right here and it'll still be okay. But as for delta math, just make sure that it matches to 168 degrees. Okay. I'm just drawing it like this so I have space, all right? Okay, so here we go. This is 168 degrees. Most important step, we draw a triangle, so we hug the x-axis. So our reference angle is right down here. I know that this makes a semicircle. So to get that pink theta, that would just be 180 minus the 168. That'll give me the leftover, which is 12 degrees. Okay, let's keep going. Okay, 237. Try this, press play when you're ready. 237 is somewhere down here. In quadrant 3, we hug the x-axis. So our theta's right there. 237 is from here to here. That's 237. Did I already do this one? I did. Okay, I'm crazy. Let's move on to this last one. Okay. So then you take off the training wheels, right? They don't give you that unit circle anymore, right? That graph, but you draw it on your own. So here we go. Try this one here. Press play when you're ready. Okay. So here you draw it out. 286 I know is a little bit past 270, so I know we're in quadrant 4 here, okay? So I'm going to go ahead and draw my terminal side. I'll illustrate it. This right there is 286 degrees. Most important step, draw your triangle, hug the x-axis. So you got your little theta right here. Logically, how do I find out theta? Okay, here's what we do. I know that a full circle makes 360 degrees. So to get that theta, that red angle, that's really just 360, the full circle. Take away all that purple. And then what does that give me? What, 74 degrees? That is my reference angle right there. Now, why reference angles are so important, we'll talk about that later. Okay, your job is to just figure out what the reference angle is. All right? Okay, try this one here. Press play when you're ready. Okay, here we go. 330 is definitely in quadrant 4. Okay, so that's 330 degrees. Again, it doesn't matter where you draw it as long as you're in the right quadrant there, okay? Most important step, you draw your triangle to hug the x-axis. Do not hug the y-axis, you guys. Always hug the x-axis. That makes things significantly easier. So then we have our reference angle theta there. Logically, to make sense of this, I know that a full circle makes 360. So if I take away all that red, I'll get that purple theta left. So theta is going to be the full circle minus the angle that we have there, which is 30 degrees. Okay, and that's it. Do I have one more? I think that's it. Pretty straightforward, but if you have any questions, just let me know, and we'll go from there.